Welcome back. Every day you type website names like google.com or youtube.com into your browser. In just 1 second, the website opens. But do you know what actually happens in that 1 second? There is one thing working behind the scenes: DNS. DNS is the backbone of how the internet works. Let us start with DNS. DNS stands for Domain Name System. Here is the simplest way to understand it. Think about your phone contacts. You don't remember your friend's phone number, you just search for their name and call them. Your phone finds the number for you. DNS does exactly the same thing for the internet. When you type google.com in your browser, your computer does not actually understand the name google.com. Computers only understand IP addresses, so DNS is like a giant phone book for the internet. Takes the name you type, like google.com, and converts it into the IP address of Google's server. Then your browser connects to that IP address and loads the website. Have you ever wondered when you type google.com how your computer knows where to go? Here's exactly what happens behind the scenes. What happens when you type google.com? Step 1. When you type google.com in your browser and press enter, your system needs the IP address, like a phone number, to connect to Google's server. So first, it checks locally. Browser cache, OS DNS cache, hosts file. The IP is found. Skips DNS lookup. If not, it moves to the DNS resolver. Step 2. Now your computer asks a DNS resolver to find the IP. This resolver could be your ISP's DNS, Google DNS, Cloudflare DNS. Its job is to find the correct IP address. Step 3. The resolver first checks its memory. Do I already know this website's IP address? If yes, it gives the answer instantly. If no, it goes and searches for it. Step 4. The resolver asks a root server. Where are the .com name servers? The root server doesn't give the IP. It directs the resolver to the .com TLD, top-level domain servers. Step 5. Now the resolver asks the .com TLD server. Who handles google.com? The TLD server does not give the IP address. It responds with the authoritative name server for google.com, the server that actually knows the correct IP. Step 6. Now the resolver asks the authoritative server, what is the IP address of google.com? This server returns the actual IP address. Step 7. The resolver sends the IP back to your computer. It also stores it in cache for a limited time, TTL, time to live, so future requests are faster. Step 8. Now your browser uses the IP to connect to the server. It performs TCP connection, three-way handshake, HTTPS, TLS handshake for secure connection, sends an HTTP request. Step 9. The server responds with the website data, and your browser displays the page. Whenever you type a website like google.com, DNS doesn't just give an IP address. It also uses something called DNS records. DNS records are like instructions that tell the internet what to do with a domain. Now let's start with the A record. This is the most basic DNS record. Connects a domain name to an IPv4 address. So when you type a website, the A record tells your browser the exact server IP. Next, we have the quad A record. Connects a domain name to an IPv6 address, just like an A record does for IPv4. CNAME record, also called an alias. A CNAME is a nickname for a website. Instead of pointing to an IP address, points to another domain name. CNAME does not store an IP, it just redirects to another domain name. You cannot use name and a record together for the same domain name. Then comes the MX record, mail server. This tells where emails should go. Without MX records, emails won't be delivered. After that, the TXT record. This is used to store text information, mostly used for security and verification. This helps prevent email spoofing and fraud. After that, the NS record, name server. This tells which DNS server is responsible for the domain. Basically, it says, go ask this server for details. Then comes the SOA record, start of authority. This contains important info about the domain. Primary DNS server. Admin email. Date rules. Every domain has exactly one SOA record.